Hi, this is Akshay, and in this video we are going to take on displacement reaction, another type of chemical reaction. First, we will try to understand what's the definition of displacement reaction. And remember, that is those chemical reaction in which most reactive element displaces the less or least reactive element from its salt solution are called displacement reaction. So, most reactive element means for the displacement to take place, the element required to be the most reactive element, yes, most reactive element displaces the less or least reactive element from its salt solution. So one thing is that is the element which is going to carry out the displacement required to be most reactive. Okay, and the element which has to be displaced, that should be less reactive or least reactive. Present, that element needs to be present in a salt solution. So means most reactive metal will displace the least reactive metal, and the displacement will take place from the salt solution of less or least reactive metal. So that's how the displacement is going to take place. But how do we come to know that is which element is most reactive or which is less or least reactive? And as far as elements are concerned, we are generally going to categorize them into metals and non-metals. So displacement reaction can be given by both metals as well as the non-metals. In case of metals, you need to know that how a given metal can be more reactive or less reactive. But firstly, we must know that what is reactivity. Means the speed by virtue of which metal tend to lose their electron, called the reactivity of that very metal. That is called the reactivity, the speed with which the electrons are being lost by a metal. Because metals tend to lose electron in order to acquire the stable electronic configuration of nearest noble gas. So how quickly a given metal can lose its electron will determine its reactivity. If a given element is just losing its electron in a flash, then that kind of element, if it is metal or it is gonna be a metal, is gonna be more reactive. And as far as the non-metals are concerned, the basic characteristic about non-metal is that they tend to gain the electron in order to acquire the stable electronic configuration of nearest noble gas. So how quickly a given non-metal gains the electrons is going to determine the reactivity of that very non-metal. How quickly means the speed by virtue of which the electrons are being gained by a non-metal is going to determine the reactivity of that very non-metal. So that's the opposite way to understand both the, you can say, that is the reactivity of metal as well as non-metal. So remember, metals as well as non-metals respond to displacement reaction. In this very video, we are going to take on two examples. One example involved the, you can say, that is the displacement reaction coming from metals, and another is coming from the non-metals. Let me tell you that is, yes, during the displacement in which the metals are present, that displacement is known as the cationic replacement or cationic displacement, because metals tend to release cations. Only one cation can just displace the another cation. Similarly, in the case cation means positively charged ion, and metals give cations. And in the case of non-metals, they tend to form anion, negatively charged ion, and hence in the displacement which is being seen in the case of non-metals, it is always gonna involve anionic replacement. Means one anion is going to displace or replace, you may say here, the another anion. So that's how the displacement reaction is gonna occur. But firstly, let me take an example coming from the metals here. Means a metal is added into a salt solution of another metal. And just to see, but how that displacement gonna take place, we need to understand the mechanism in order to go to the depth of this very chemical reaction. But firstly, let me tell you that is, yes, which metal is most reactive or which metal is least reactive. There is a series of metals in which metals are arranged in the order of decreasing reactivities in such a way that the most reactive metal comes on to the top, whereas the less or least reactive metals comes down to the bottom. Such a series of metals is called reactivity series because it gives you an idea about the reactivity of those metals involved in that very series. This series is also known as the activity series because it tells how active the metal is, how actively the metal is going to lose its electron, and that's why it is also called activity series. Or since this is a series of metals and hence it is also known as the metallic series. So there you are, this is the series meant for you. You need to just have that series in your mind in order to take on or understand the displacement reaction, and also come to know whether in a given chemical reaction displacement will take place or not. If you are not having a knowledge of this very series, I am sorry to say that is, you can't understand the crux of the displacement reaction. So firstly, this is the series in which the metals are arranged in the order of decreasing reactivities with potassium, sodium, calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. So this is a series of metal. All are metals involved except this one, use no hydrogen. In the another video we will discuss, that is in the company of metals, what the hydrogen is doing. It's gonna be a separate kind of a question we will discuss in another video. But here the most reactive metal coming on the top, and as we are just moving down towards the bottom, the reactivity goes on decreasing. It means the metal which is coming one after another is going to be less reactive, and that's how you are going to come to know that is how the reactivity is going to put into place in this very displacement reaction. So remember, the reactivity is giving us an idea of how quickly these metals are going to release their electron. The speed is going to be speed is going to determine the level of reactivity of these metals here. So we have got this very series, and now we are going to take an example here. The definition is already being just mentioned here. Most reactive element is going to displace less or least reactive element from its salt solution. But as we are taking on the metal, so we are going to say here the most reactive metal going to displace the least or less reactive metal from its salt solution. And let me take an example by taking copper sulfate solution. Here it is, I have taken copper sulfate solution. Yes, aqueous solution of copper sulfate, salt solution having copper in it. Okay, this is having blue color due to the presence of cupric ion. Yes, it has got cupric ion, and that's why it imparts blue color to the solution. Now I'm adding a piece of magnesium into it. Magnesium is being added into cupric sulfate, aqueous solution of cupric sulfate. So what is going to happen? We are gonna write down the reaction here. It is magnesium, and here is CuSO4, cupric sulfate, and reaction is going to take place. You need to just see, here it is magnesium and here is the metal present. So whether this displacement reaction will take place or not depends upon the definition you have learnt a bit earlier. That is, the most reactive metal can only displace the less or least reactive metal from its salt solution. It means magnesium can only displace copper from its salt solution if magnesium is more reactive than copper. And now we should know that is whether magnesium is more reactive or not. Yes, that is the reactivity series where you can come to know that is, this is where magnesium is lying, and here it is somewhere here. It is copper. So any metal which is coming on the top as compared to the another metal which is coming below the down the bottom, is going to be more reactive. So magnesium is more reactive than copper, and hence the displacement will take place. Only the most reactive metal will displace the least reactive metal. So it means magnesium will displace copper from its salt solution. And to give you magnesium sulfate and copper, during this chemical reaction you will just see a perceptible change in colors. The blue color of copper sulfate is going to damage, going to fade away, going to disappear due to the formation of magnesium sulfate having white color. So this disappearance of color would be noticed here. And at the same time, magnesium is being coated by the reddish brown copper there. Means copper is going to wrap around the magnesium there. So that's this very copper is going to deposit on the magnesium, piece of magnesium you have dipped over here. So that's how the displacement reaction take place. Now this is the simple way, but we must know that how that displacement has occurred, and this is where the mechanism comes into play. So let us see here. I'm just moving towards mechanism. Here it is magnesium, and this is copper sulfate. You have taken copper sulfate or cupric sulfate in aqueous form. It means why? Because this is salt. When it is taken in aqueous form, it tends to dissociate. It tends to dissociate to give ion, and this cupric sulfate will give you cupric ion Cu+2. This is cupric ion, and it is sulfate ion -2. This is also in aqueous state. Now how the displacement gonna take place? That very metal will displace the another metal which is most reactive. You know, magnesium is most reactive than copper. It means magnesium will carry on the displacement. But how? Remember, magnesium, in other words, we will say that magnesium is having more electropositive character. What is electropositive character? The tendency of a metal to lose electron in order to acquire the stable electronic configuration of a nearest noble gas, thereby becoming positively charged ion, is known as the electropositive character. Metals do show electropositive character because they tend to lose the electron and thereby getting converted into positively charged ion. That is called electropositive character. So remember, only that metal can bring about the displacement which is having more electropositive character. It is a competition going on between magnesium and copper. Magnesium is going to have a upper hand because magnesium is most reactive, or magnesium is having more electropositive character than copper. What does it mean? Having more electropositive character means the magnesium is having a greater tendency to lose its electron as compared to copper can do. So it means magnesium is going to just release or give its electron so that it can bring about the displacement over here. But how? Let us see here. Magnesium is releasing two electrons. Two electrons are being lost by magnesium. That is called electropositive character. Magnesium is losing two electrons, loss of two electrons. In other words, magnesium is undergoing a process of oxidation. Yes, it is a process of oxidation. Because what is oxidation? I have already just uploaded a video related to oxidation and reduction under the banner of redox reaction. Oxidation means that is magnesium is losing electron. The loss of electron is called oxidation. And since magnesium is having more electropositive character as compared to copper, and hence it tends to lose its two electron very quickly. So these two electrons are meant for cupric ions, because here you are watching it is +2. It means it has got a deficiency of two electrons. So it is in need of two electrons, and that need is going to be fulfilled by magnesium. So magnesium firstly going to just displace cupric ion from here, and then it will just join hands with sulfate ion, and that's how the displacement gonna take place. Now see, that is, yes, these two electrons are being just given to cupric ion, and cupric ion undergoes the process of reduction. This is the reduction. Reduction is known as the gain of electron. So cupric ion gaining two electrons, and what's gonna be the scenario here? +2 with the gain of two electron. You will see that cupric ion having charge plus 2 minus 2 plus 2 minus 2 cancel, and it turns out to be copper. Yes, here you are. Yeah, it is copper solid. Now, now there is no match at all between atom and ion. No match at all. Day and night they are. No match at all. It means now copper can't join with sulfate ion. So it's being kicked out. That is the number one step involved during the displacement. That is, yes, firstly, you need to remove this cupric ion from the salt solution, and you have done it in a style. That is magnesium losing 2 electrons and kicking out cupric ion in the form of copper. But magnesium does not remain the same as magnesium, because during chemical reaction every bond has to undergo a change. So is the magnesium. Magnesium, when it has lost 2 electron, it got converted into magnesium ion Mg plus 2 and goes into aqueous state. Now that magnesium ion and sulfate ion are the best friends here, because both are meant for one another. It is deficient in 2 electrons and it is in excess of 2 electrons, and they are gonna join hands together, and what is gonna be the result here? There you are, Mg plus 2 SO4 minus 2, and you will get Mg SO4 in aqueous state here. And there you, this is Mg SO4 in aqueous state. No, but you are noticing here, that's the mechanism of a chemical reaction here. Most reactive metal, how the most reactive metal displaces the less reactive metal from its salt solution. Two steps oriented reaction here. One undergoes oxidation, that is the most reactive element, and thereafter it brings about the reduction of the metallic ion present in the salt solution. That's the one step. And the second step, the metal that is most reactive has turned into the positively charged ion, or positively charged ion and negatively charged ion joined together to give you magnesium sulfate. And you can see very much clearly here that is, yes, now in the company of sulfate ion it is no more a copper, but it is right now the magnesium ion, and it has been MgSO4, white color it has got, and that's how the color is going to disappear, because blue color of copper sulfate is due to the cupric ion. As cupric ions begins to die, as cupric ions begins to change into copper, the blue color begins to disappear, fades away, because blue color was due to the cupric ion. And when all the cupric ion got reduced into copper, then blue color will disappear altogether completely, and the color is going to come due to magnesium ion, and it imparts white color, and that blue color just gonna be damaged to give you white colored magnesium sulfate. But the magnesium you have added has got a cover or a layer of reddish brown colored copper. This copper is going to deposit on magnesium piece, and hence this kind of a reaction you are seeing here, where oxidation as well as the reduction going hand in hand, and it is called a redox reaction. And I have told you in that very video here, we have learnt redox reaction. I have said that is, yes, the first definition of oxidation and reduction, which involves electronic concept, the loss of electrons and a gain of electrons. That concept is gonna be studied in displacement reaction, and we have done it here. So that's the cationic replacement. One cation is replacing another. You can say that is magnesium is replacing this very cation, that is cupric ion, into copper, and thereby becoming cation as well. And that's how this reaction is gonna take place. So that's the one type. Now we are gonna come across the non-metals, and non-metals, the same story remains the same, that the most reactive non-metal going to displace the less reactive non-metal from its salt solution. And let me take an example here, chlorine, and it is being passed through sodium bromide, aqueous solution of sodium bromide, and what you are gonna get here, that is NaCl in aqueous state, N plus bromine gas. Now this chlorine, remember, now the competition is between non-metals. Now chlorine is non-metal. Here it is. Chlorine is non-metal and bromine is non-metal. And remember, chlorine is more reactive than bromine because of the reason that the speed with which chlorine gains the electron is more as compared to the speed with which bromine gains the electron, because non-metals are known for gaining the electron. So how quickly a given non-metal gains the electron determine its reactivity. Chlorine is having more speed as compared to bromine to gain the electron, hence chlorine is more reactive than bromine. So there you are, chlorine is more reactive than bromine, and that's why the displacement will take place. Chlorine will replace or displace bromine from its salt solution to give you sodium chloride and bromine Br2. And here it is 2, and you are going to multiply it by 2, and it is 2, it is 2. This is the reaction. But how the reaction proceed? Anywhere you can get this kind of a chemical reaction, but the mechanism is hard to come by, and that's what you need to learn, the way the reaction is gonna proceed. And let us take it. You can see here, this is the aqueous solution of sodium bromide. Obviously it will undergo the dissociation to give you two ions it is made up of, that is sodium ion, here it is, and bromide ion. But since it is 2 NaBr, it means you will get 2 sodium ion and 2 bromide ion, plus chlorine, 2 atoms of chlorine, one is Cl here, another is Cl here. Okay, now the point is that how quickly a given non-metal gains the electron determine its reactivity. You know, chlorine has got a more speed to gain the electron, and that's why chlorine is more reactive. But the question is that how it will displace this very bromine from its salt solution. And see here, the reverse will take place. What you have learnt in the case of metal is gonna be reversed over here. That is, yes, this chlorine being more electronegative. Yes, electronegative. What is electronegative character? That is, non-metals tend to show electronegative character, and the character, what is electronegative character means, that is, non-metals have a capacity to gain the electrons in order to acquire the stable electronic configuration of nearest noble gas, thereby got converted into negatively charged ion, and that kind of a character is known as the electronegative character. So same is here, chlorine is having more electronegative character than bromine. What will it do? It will gain one extra electron present in bromide ion, and during the process, yes, this one electron is being gained by chlorine, and this one electron is gained by another chlorine here, thanks to the high electronegative character it has got as compared to bromine. And that's how the displacement is going to take place. Just look at here and see the difference. What has happened before is going to be in reverse gear here. So then it has lost loss of electron. Electron is being lost here. Loss of electron is known as the oxidation. It means bromide ion is undergoing the process of oxidation. This is oxidation, and this chlorine is gaining the electron. It means it's going under the process called reduction. And what Cl is going to become? Cl minus 1. It is called chloride ion. Here it is, and it enters into aqueous state. Similarly, this one electron is coming towards chlorine because chlorine is having more electronegative character than bromine, and hence this extra electron of bromide ion is going to be gained by chlorine thanks to the high electronegative character chlorine has got in comparison to bromine. And chlorine will not remain the same because it has gained one electron, and it will go transformed into chloride ion, Cl minus 1. But same is going to happen with bromide ion. It will also not remain the same. And what is happening here? Bromide ion has lost the electron. It will convert into Br because that extra electron has gone and charge is also gone. Br, and this same, it is also going to be transformed into Br. So Br, that is going to give you bromine gaseous state. Here it is. This is bromine. And what's next here? Yes, sodium ion, chloride ion, and they are gonna be the best friends because they tend to mate for one another. One is positively charged ion, another one is the negatively charged ion, and under the strong electrostatic force of attraction, they come together and just form sodium chloride and ionic compound here. So Na positive and Cl negative. it will give you NaCl in aqueous state. Similarly, Na positive and Cl negative, another one. It will give you another NaCl in aqueous state. So there are how many? One is NaCl here, another NaCl is here, and it will give you 2 NaCl in aqueous state. And that's how this reaction is going to proceed. 2 NaCl in aqueous state and the bromine gas is going to form, and that's how the displacement going to happen. Remember, this is anionic replacement, always being shown by the non-matters. So that is all about the displacement reaction being shown by both matters and non-matters. Just if you have got any kind of a doubt related to the mechanism or the chemical reaction or any kind of a query you have got, you can post that question in comment section. I would love to just hear from you in due course of time. Thanks.